Hey everyone, I'm Niru. We're gonna kick off the village talk right now. This is, I think I'm getting feedback from this one. Okay, cool. So hey, I'm Niru. We're gonna kick off the talk right now. Today's talk is about cross-site scripting. It is a 101 talk, so if you're here expecting in-depth stuff about cross-site scripting, not the talk for you. But if you're here just to kind of get to know what XSS is and try your hand at a beginner-friendly CTF challenge, you've come to the right talk. So before I kick things off, I do want to give a shout out to my colleagues, Jenna, David, and Koto, whose slides I've liberally used here. And big shout out to them for letting me borrow their slides. So a brief intro, I'm Niru. I'm a security engineer at Google. My day job is to break into things as a red teamer. In my free time, I do try to write CTF challenges, be it web or mobile or cloud. I'm also one of the core organizers of the BSidesSF CTF, so you'll probably see me at the CTF room. We swing by there. So if you have any questions after this talk, feel free to drop in there, and I'm happy to field all of them. Cool. With that, let's dive into XSS. Web kind of has its own different class of vulnerabilities, which is not surprising, right? Like web kind of sprouted out of nowhere, it became a really big thing, and security has been running behind that carriage since it started. One of the classes of vulnerabilities that you'll see a lot in web is injection-style vulnerabilities. What does that mean? This typically happens when user data is taken and just plopped in and treated as code. So it happens when user-supplied data isn't treated as data, but is treated as code. And XSS is just a type of injection vulnerability which is dealing with JavaScript. So attacker given JavaScript is added to the request. It goes to the server, comes back in the response. That's at its core what XSS is. So let's take this example here. You can see that the title is something that the user controls, right? It can be something as innocuous as, let's say, corgi, because corgis are awesome, and everyone should love corgis. So let's say we put corgi in there. It gets plopped right into the header field, and you see it in the response. But not all people using your app are good people. Some of them might try breaking into it. So what happens if they try to plug in JavaScript? Let's use the infamous alert box that everyone loves to use in XSS. If you're not escaping your responses or the user provided data, it's just going to come back in the response. And the browser goes, well, this is JavaScript. I'm going to render it. It doesn't care who supplied that JavaScript as long as it shows up. The browser is just going to render it. So this particular type of injection issue is what is XSS. And at its core, like we just discussed, it happens when user-supplied data is treated as code and not as data. And at the end of the day, the browser doesn't care what's being supplied to it. It's your job as an application developer to actually make sure that it's properly escaped. Before we jump into XSS, one of the things that we need to dive into is context, because this is really important for you to understand how to write XSS payloads that work. As you can see, a web page kind of has a lot of different contexts. You have HTML context, you have URL context, you have JavaScript context. It gets really confusing really fast. And depending on where your data ends up as an attacker, you need to make sure you understand what that context is, and you can run your payload within that context. And one of the things you will also notice is you can have nested context as well. And what do you do as someone who's writing a web app? Do you try to juggle all these rules in your head? The short answer is no. And that's where we'll talk about template systems towards the end for mitigations. But enough about trying to protect things. We came to this talk to try and understand how XSS works and how to break things. So let's get back to that. Let's pick a very simple example, and let's walk through it to try and understand how to write an XSS payload. Here's a very simple image tag. The foo bar is the user-supplied data, and you control it. So if you as an attacker control that, how do you make this into an XSS? First things first, to write a payload that actually works, you need to be in a JavaScript context. because you need to be able to run your code. And right now, where you're at is inside the name of an image or the source of the image, which isn't really JavaScript context. So this is not going to be useful for us. So first things first, let's get out of this context and enter a new one. So all you have to do is add that little quotes there, so you get out of this context right now. Next up, great, this is not a JavaScript context. We can't run our payload here, but we can make it a JavaScript context, and you're inside an image tag. So why not leverage event handlers? So let's say we add an image that doesn't exist, and we just say, on error, you're going to do what I say you should do. So now that we've closed the quotes, we're opening a new context with on error and a quote. Now comes the fun part. This is where you write your actual payload. Since you're in the JavaScript context, fine, let's start with the alert box. I think that's where all of us start our XSS payloads. Let's do the infamous alert box. So we added that. This is an optional step. You've already achieved XSS. This will run if the user supply data isn't properly escaped. This is endgame. But you can go a step further. Right now, what's going to happen is that .png closing brace is going to show up on the web page. You don't want that. Don't be sloppy. Be better. Hide your tracks. So how do you hide your tracks? You can do something as simple as just introduce an additional parameter A, because A is the first letter, and it's easy to remember. We just put A equals quote. So now it kind of closes out all things at the end, right? So .png quote closes out. You get the end tag for the image. So you get no visible indicator that some shenaniganry is up. Great. Now that you understand how to roughly write payloads, what XSS is, let's dive into the different types of XSS, because understanding the different types of XSS will help you understand where to look for XSS. The first one is reflected XSS. This is fairly simple. You, as an attacker, are supplying JavaScript payload. It makes its way to the server, and it comes right back to you. Hence the name reflected. A good example for this is a search query. Like in a search query, imagine entering the JavaScript payload, makes its way to the server, comes back as you searched for so-and-so. And that's a good example of places where the response is thrown right back to you. And that's a good reflected XSS example. Next up is stored. Reflected was nice. It went to the server, came back. But what if I want to do something else? Like, what if I want to hit more people? You can send the reflected XSS payload to someone. You can see it get executed. But stored XSS is kind of cooler, where what you're giving it, the payload as an attacker to the server, it gets stored in the database, and it gets fetched every single time someone visits that page. A good example of this is, let's say you go to a forum, you find a place where you can inject this. You inject this payload, it gets stored into the database, and anytime someone comes and visits that forum, your comment is like picked back up and served to them. So the main difference here is that it is actually stored on the server component. Finally comes DOM XSS. This one is different from the two types we just covered, where the server is typically not involved. So everything happens on the client side. A good example of this is, you get the pound sign oftentimes on the URL. That's the location hash. And this is actually never sent to the server. It's only ever viewed by the browser. It's oftentimes to shift your view in a page. It can be used to change the colors on the page. So what happens is the user supplied data is taken, and it's actually processed by the JavaScript on the page itself, and it's plugged into the page. So in this case, you'll see that U is actually a parameter, so variable that's actually filled in with user supplied data, and it's plugged all the way into the inner HTML and written back, right? So everything happens on the client side. There's no server involvement here. So with this knowledge in mind, you now know where to look for the various types of XSS. It is a pretty prevalent attack class, vulnerability class. You're probably going to stumble into it at some point. Obviously, don't go willy-nilly and try these things. Maybe try it through a bug bounty program, try it through CTFs. Be responsible with this knowledge. Now that you know how to find XSS, what are the different types of XSS, let's briefly also discuss how to mitigate XSS. At the end of the day, what we can do as people who write web apps is to make sure that user control data, we don't trust it. We never trust user control data, and we always make sure that we use template systems that are going to do strict contextual auto-escaping for us. So that way you don't juggle any of the rules in your head, everything's taken care of for you by the template systems. The other thing which is really cool and is being introduced now is trusted types. Koto is actually the one who introduced it. And it's really cool for locking down risky functions that you're coming across in JavaScript. Finally, CSP. Think of this as a safety net. If everything goes wrong, CSP will hopefully catch you. But CSP is not a panacea. You can't use it as a substitute for using template systems or escaping the user content. Cool. With the theory out of the way, let's jump into the demo. We'll be using the web tutorial 1 right now. If you have your laptops, feel free to follow along, or you can also try this later. We're going to keep this running until end of day tomorrow, probably even further than that. So these web tutorial challenges 1, 2, and 3 are set up to be beginner friendly. And the first one is very basic. You can give it a script alert 1, and it will absolutely work. There is no escaping that's happening on the server. So you can check out these challenges at ctfbsides.net, or you can just hit that URL directly. I will leave the slide up for a second in case people want to pull the URL. And next one. Cool. The goal of this is not to get an alert box, because that's the other thing about XSS. You can use JavaScript. You can do anything you want. In this particular case, we want you to focus on learning how to write good XSS payloads. It's not about writing the alert 1 box. We are better than that. What I want you to do is steal the XSS1 flag. However, there's a catch. You can't access the flag as players. Only the admin can access the flag. So what do? This is a bit of a contrived example, but it works for what we're trying to teach you. Any request that you send from your session will be sent to the admin, and the admin will do the exact same thing. So whatever you do, the admin is going to mirror that. So while you can't get the XSS1 flag, the admin can absolutely get that flag. So what do you do in terms of writing a payload? What you can do is you request the flag, you read the flag, and you add the additional step of you write the flag somewhere where the attacker can read the flag. So it's now one additional step, but it does get you to the flag. Great. You might be like, hey, I don't know JavaScript. I do want to learn it later, but can you break it down for me and explain how this payload works? Well, that's where XHR comes in. I know the slide colors are not great, but I'll upload the slides and you can all see it. But at the end of the day, what this payload does is it uses XML HTTP requests to say, hey, I want the flag. Give me the flag. And then it reads the contents of that response and then sends out another request. In this case, the last request is to something you control as an attacker. So it says, give me the flag, reads the flag, sends you the flag. So 3 little steps to get you to the goal. Great. You might be like, OK, I don't want to set up a server. I want the flag. What's the best way to get to the flag? You can use services like RequestWin, which is really for testing to see, hey, if I send a request, can I just get it posted somewhere, and I can just pick it up and do some testing? RequestWin is great for it. You can actually set up a public bin for it, and anything you send to it, you will be able to view it in the sidebar. With that, let's jump into the payload. And I'm going to mirror my display in a second. Awesome. I'm going to escape that. You can see that I've already set up a request bin there. Let me copy that payload for now. First things first, let's actually go to this page. We try to make this easy for you and said, hey, if you're going to look at CSP and you don't know what CSP is, we've actually built in hints here so you can actually look at the CSP policy. Alternatively, if you are using Chrome, you can actually right-click inspect. You'll see the network tab. You can refresh it. You'll see the CSV headers right there. So let's actually copy the CSV headers for a second and plug it into this really nifty tool that our colleague wrote, which I right now have the payload. I'm going to park the payload here and copy this. So you can actually check the CSV policy using CSV Evaluator, really helpful tool. Tells you like what can possibly go wrong with your policy. If you're running any tests or you're writing apps that require CSV, do feel free to test this. And in general, CSV is a lot easier if you build it from the ground up when you're writing the app versus plugging it in later. So just something to keep in mind. Cool. So we have this nifty little site. Let's try the script alert payload first. Voila. You know there is an XSS now. And you can actually inspect or view source, and you'll see that I am displaying the payload for you just so you know what you entered. But you can also see it's getting rendered. This is the part that's actually being run because the browser just goes, oh, there's JavaScript. I should run this JavaScript. So now let's run our payload. What this is going to do is read the flag. It's going to request the flag, read the flag, and send it to my request bin. Great. So if I view this and I try not to inspect it, I'm going to refresh that. You'll see that I am requesting the flag, and you can also see that the flag is being sent to my server, my request bin. So you know this is working. So let me switch over to my request bin, and you will see two requests here, because the admin mirrored my request and helpfully sent me back the flag. So that's about it. It's as simple as that. So now that you've tried your hand at this, go ahead, if this is your first time trying it, try the web tutorial one, try to solve this. Again, the solution is up. I'm also going to post the slides soon on my Twitter account, so feel free to look at it there. One thing I would mention is Web Tutorial 2 is a slight variation of this. So try your hand at that as well. And again, use CSV Evaluator. It's going to tell you where to poke holes. And Web Tutorial 3 does have a twist. But if once you all figure out XSS, I think you can solve it. So that's pretty much it. So thank you, everyone, for coming to this talk. I will be at the CTF Village for the rest of the time here, and you're welcome to hang out there. And that's about it. So thank you.